Hello, in this problem we're going to be performing a dimensional analysis to establish the Sherwood, Reynolds, and Schmidt number as an appropriate dimensional group. So in this problem we have liquid flowing down the inner walls of a vertical cylindrical pipe, as we can see here. And we also know that there's evaporating gas going up this cylindrical pipe. We also know that we have important variables to note in this problem that pertain to this exact scenario. The density, diameter, viscosity, velocity, diffusivity, and mass transfer coefficient. And we want to make a dimensional matrix to solve this problem. So the important units that we need to know in order to solve for these dimensional groups is as follows: the diameter in meters, the density in kilogram per meter cubed, the viscosity kilogram per meter per second. We have the velocity in meters per second, and we also have the mass diffusivity coefficient, which is meters squared per second, and we have the mass transfer coefficient, which is in meters per second. So we know that we have three different groups, and those three different groups are the length, the time, and the mass. So we're going to write it as follows. I'm going to write mass, length, and time. So now we're going to change these in a different variables so that we're able to write the dimensional matrix. So we know the Kc is in length over time, the velocity, which is in also it's over length over time, and the density is right here. It's in mass over L times what is it, seconds, time, oh yeah, T. And the viscosity, oh, I mixed these up. This one, yeah, that's why I got confused. This one is supposed to go over here. The length, the mass over the length multiplied by time. And for the viscosity, this is the viscosity, this is the density. The density is mass over L length to the third power. We have L squared over time. And we have L, just for the length. So now let's put it in. So for this one we have 0, 1, -1. This one length, there's 1, same thing, -1. This one has 1, -3, 0. This has 1, -1, -1. This is L. This has 2, 1, 0. This just has 1, 0, 0. Now that we found the dimensional matrix, we can put this into Python. So we're going to write it down: 1, 1, 0, 0, 1, 1, -3, -1, 2, 1, -1, -1, 0, -1, 1, 0. And if we do the rank of this into Python, we get that it's equal to 3. So we know that the number of dimensional groups is equal to 3. And how do we know that? We know that because of the Buckingham method. And that allows us to find the number of dimensional groups in a problem. So the formula for that is I equals n minus r, where I is the number of dimensional groups, n is the variables in the problem, and r is the rank from obtaining this dimensional matrix. So we're gonna plug everything in. We get 6 variables, 1, 2, 3, 4, 5, 6, and the rank, which was 3. So we get I equals 3, and that's important. So that means we need to choose 3 groups that we'll use for the dimensional groups, 2 and pi 3. And the 3 groups that we're gonna choose is we're gonna make sure that it has all the variables in the group. I'm gonna choose D, A, B, the diffusivity. I'm gonna choose the density, and then I'm gonna choose the diameter. I'm gonna do that for all 3 because we found the 3 groups. And we're gonna assign them some exponents, A, B, C, D, E, F, G, H, I. And the other 3 groups that we didn't put in there, we're just gonna spread them out. We're gonna do KC, we're gonna put the velocity over there. What else are we missing? Oh yeah, the viscosity, yeah. So we're gonna separate those 3 groups, and now we're gonna solve for the exponents. So, let's do it. So, for the diffusivity, we know it's meters squared per second, A. Density, kilogram per meter cubed, B. Diameter is in meters, C. And then we're gonna put the last one, it's not gonna have any exponents on it, so we're just gonna put meters per second on that one. And we're gonna do mass, second, meters, second, and kilograms. So we need to find the exponents, what the number of the exponents are. So we're going to make these dimensional groups. So, meters squared per second. So for meters, we're going to do 2a minus 3b plus c plus 1 equals 0. That's for meters. For seconds, minus a, it's going to be 0, 0, minus 1 equals 0. So we know a is equal to minus 1. For kilograms, there's no kilograms over there. We're going to have b, okay, no kilograms, no kilograms there, so we know b is equal to 0. So now we can plug that in. 0, this is negative 1, so it's going to be negative 2 plus c plus 1 is equal to 0. So it's going to be negative 1. So c minus 1 equals 0, c equals 1. So for the first dimensional group, we found out that that is equal to, okay, so a is negative 1. So DAB, and we also know B is 0, so there's none of that. The C was 1, was on top, and then that's KC. So we know that that is equal, we know this is equal to the Sherwood number. So we found the Sherwood. Now we're gonna do the same thing for the second. Pi, no, I'm not gonna do it that way. Actually, we don't even have to do it for the second one. I just realized that the mass transfer coefficient and the velocity have the same units, length over time. So we do know that it's the same thing, but it just replace it with the velocity and like that. So we end up finding that. And we know that's equal to the, okay, I'm gonna fix it. We know this is the Parcel number. Parcel. Now let's find the third dimensional group. Because we need to still figure out the Schmidt and Reynolds because we're trying to find the dimensional groups for all three. So let's set it up. Okay. So we have meters squared per second, and that's G. We have kilogram per meter cubed, that's H. And we have diameter, which is I. And we know the viscosity is equal to kilogram meters per second. So now we can solve it. So let's write down meters, write down seconds, write down kilogram. So for meters, 2G minus 3H plus I minus 1 equals 0. For seconds, minus G. No seconds here, that's 0, no seconds here. Minus 1 equals 0, that means G equals minus 1. Now for kilograms. There's no kilograms here, that means it's 0. What about this one? 1. So it's H. H plus 1 equals 0, so H equals negative 1. So let's plug it in. Negative 2 plus 3 plus I minus 1 equals 0. 1, 1. We find out that, wait a minute. 1 minus 2 plus 1. Okay, that's 1 minus 1. Yeah, that's equal to 0. I was thinking something else. Okay, so we found out the dimensional groups. So this is equal to 0. H is equal to negative 1. And G is also equal to negative 1.